Next, please welcome Peter Siebert, Technical Expert in Business Development, and Gilbert Brindley, Director, both from UHPC Solutions North America.
Good morning. This morning we're going to be talking about bridge deck preservation using ultra-high performance concrete. Peter and I have worked together for several years now. We work for UHPC Solutions. UHPC Solutions North America is a specialty contractor who installs ultra-high performance concrete. We are not a material supplier, so that's my first disclaimer. We've got an experienced workforce and cutting-edge equipment. We've spent the last 4 years developing paving equipment and mixing equipment for the application of UHPC for bridge overlays. We've performed a number of field cast connection projects, as well as worked with link slabs and shotcrete and other applications. We work across the United States. We obviously work with ABC Construction. We partner with, one of our partners is involved in hydro demolition. That's Wallow. Wallow is a Swiss-based general contractor that teamed up with Basilico, which is a New York-based general contractor, to create UHPC Solutions North America. I'm gonna introduce Peter Sybert. Peter is a former ductile guy, so he's got a lot of experience with UHPC, and he's been our technical expert and helped us on the sales tour for introducing UHPC to DOTs, owners, and engineers in the U.S.
First I want to talk about UHPC, ultra high performance concrete. What is the material? I'm not sure if everybody's aware of it. It's a cementitious based composite material, and it's not the same as regular concrete. As you can see, you have in the material itself, you have always a filler, a sand, and cement. You don't have coarse aggregates. It's very fine material, cementitious. It comes usually in a premixed material. That gets added superplasticizers, waters, and steel fibers for most structural applications. And the dosage of the steel fibers varies. It can be 2% for the self-consolidating mixes you can see in joint fill applications, connecting precast elements together, or it can go up to 3.5% that's mainly used in overlays. This material has very high strength. You get extra stiffness, and with the fibers in there, that provides ductility. Due to its dense matrix, you have excessive durability, and it's impervious to chlorides and water. Generally, right now, most of the people look at it with design lives of 75 years, but data suggests it's significantly more. Just looking at some hard figures, UHPC itself, if you compare it with regular concrete, you can get compressor strengths of the minimum 17 KSI up to 35 KSI, depending how you cure it. You have what's very unique too is you can design with it with a sustained tensile capacity. That's what you can't do with regular concrete. And if we're looking at the durability, it's significantly less than 100 coulombs. I've seen test results with 18, 17 coulombs in that type of test environment. Generally speaking, these kind of properties can be reached in 12 to 72 hours. In North America, it really took off in the bridge market initially in the precast. It's in a controlled environment. It's very easy to use the material. The very first bridge was done in Iowa in 2006, Mars Hill. And then afterwards, it really took off in the accelerated bridge market, taking precast elements and connect them with a self-consolidating UHPC material. You can see in these slides here, there's slabs that can be easily put on existing bridge decks. You can replace the entire deck and then connect it with UHPC. To date, I've lost count, but there's over 300 deployments, I would say, across the US, and we have seen it across 32 states. Overlay application has been a lot slower. Overlays are very commonly used in Switzerland. They have been doing this over 15 years. They have done over 100 overlay projects over there already. Here in the US, it started more in 2016. That's when you saw the very first overlay project, which was done in Delaware. In Iowa, and then the second one in 2017 was done in Delaware. We did the first one in 2018 in Iowa. We brought paving equipment over from a very large project that was done in Chillon, Switzerland, and since then it has really grown significantly. I would say a big year in UHPC overlays was 2020. In that year, you saw over 10 bridge structures that used UHPC as an overlay, and it was done in multiple states, Delaware, New Jersey, New York, Iowa, Rhode Island, Illinois, and then just in 21 was a little slower year. We were aware of 2 projects, but there's a lot on the horizon for 22 now using UHPC. Out of all these projects that you see we've done, we have done a significant amount, pretty much the majority of the projects. So what type of overlays are out there? So these are kind of the 2 common ones. I talk about the first one, which is more for waterproofing and chloride resistance. You can see quite often thicknesses are getting put on a standard bridge deck of 1.25 inches to 1.75 inches. And then you can do structural repairs as well and strengthening the deck. We see those at deeper depths. You can go down like down to 4 inches and you can below the top mat. But there's other applications, particularly in Europe, they're adding additional rebar to really strengthening up the deck and get that additional strengthening structural stiffness. But I want to use this slide, introduce the next slide, and talk about the flexural capacity increase with UHPCs being added just on a regular deck. Federal Highways has done some work on that. If you're looking at a regular 8-inch deck and you have a number 5 top bar and a number 6 on the bottom bar, and then they were trying to see is what if just putting some overlays on there, how does that impact the flexural capacity of the deck? There's 2 aspects to look at. You have positive bending, positive moment capacity and negative bending capacity. And particularly if you're looking at the positive one, what they have shown is for a standard deck, if you would replace and add about a 1/2 inch, 1 inch, or 2-3 inches of UHPC overlay, generally speaking, the capacity will increase, which is very common because in here the UHPC, when you put in positive bending, it's going to be in compression. But generally speaking, if you add more than 2 inches to it, it's not going to do any significant increase anymore. If you're looking at the negative, putting the UHPC in tension, you can see as a 1/2 inch is pretty much 0, more or less. You get a slight increase with 1 inch, but you get 45% flexural capacity increase for a standard deck. So looking at this type of chart, generally speaking, a good sweet spot is 1.5 to 2 inches if you're looking for some flexural capacity increase. So what are the key success factors of a UHPC overlay? And there's like really 6 main factors. One is surface preparation. You really got to make sure that that surface is prepared properly. You're putting the material on there that's going to last for a very long time. Efficient mixing, material supply, proper consolidation, the curing, and the finished surface. And I'm just going to talk slightly about each of these 6 points. For surface preparation, generally for most of the overlays, often being hydromilling is being used, but the last step is really hydrodemolition. The hydrodemolition do a thin removal is very important because provides excellent bonding. FHFW has done some work on that, and you can see that because you have irregular surfaces, all these minor cracks, they're all removed, providing an excellent bond. Again, if you want to go deeper and want to expose the top mat, that can also be done with hydrodemolition. Efficient mixing is very important because you have now a process. You need to mix it, the material, deliver it, and place it. Currently, standard traditional ready-mix plants, they're not set up to mix UHPC. It can be done in ready-mix trucks, but feeding the materials in there is quite challenging. So here you can see some of the setups. This one over here is kind of the initial one. From there, we've improved the method now. We can pull up with a trailer at your site, mix the materials, and with this type of plant, we can do 45 to 60 cubic yards a day easily. This is another plant that's from our Swiss partners over there. Their target was, they want a plant, you roll up, you set up in 1 hour, you have 2 guys to operate it, use a little tablet, and this type of plant easily pops out 8 cubic yards an hour. For larger projects, particularly in overlays, we also have on-site mixing capabilities. This is for one of our plants in Switzerland. It's a 2,000 cubic yard overlay job. For this particular project, the raw materials, the constituents are brought in bulk with a cement tanker. We have silos, and the mixing plants are inside this type of plant. Material supply and placement now is very important as well. As the materials are being delivered on site, you have a hydrodemo deck, there's a removal. Depending how deep you can go in there, ready-mix trucks may not have the capacity, or the deck doesn't have the capacity to get on there. There's some exposed rebars, some puncture. Sometimes there's a potential risk for puncturing of tires. What we have noticed is, for us, is what's been working quite well for the projects. We use a buggy system. The materials come right out of the mixer, go into the buggy, and being placed immediately in front of the paving, in front of the paver. It is very important to have a continuous paving operation. We don't want to have stop, go, stop, go, stop, go. If you're looking at our paving equipment, the consolidation of the material is very important. This is a thixotropic UHPC mix, meaning it's very stiff. As the paver goes on top of it, adds some vibration to it, liquefies it, and puts it into the shape. So whatever slopes we can need, we can put crowns and the slopes on the bridge deck. You've seen air screeds quite a bit. They work, we use them too, but particularly only for small projects. Because they're limited too, they don't have the weight, they don't have the speed, you don't have controlled vibration on that. Depending on the contractor, some may not know how to set it up properly. This one's set up right, where you can see the air screed is not riding the form. Often you can see forms on the side. Contractors putting vibration into the form, and it's not going to go into the mix. And this is not very ideal for deeper depths on the overlay. We've been using an equipment, it's a thin lift UHPC paver. This works very well for UHPC overlay projects. This paver can go from 8 feet up to 30-foot widths, so we can do 2 lanes easily. With this machine, you can put a crown into the machine. It's adjustable, it's self-propelled, you can control the speeds, you can control the vibrations, and it really gives you a nice uniform surface, proper consolidation, and again, as I said, we put crowns, slopes, and we've gone easily for 6% slope, 10% slope with this type of paver. Curing, very important for all the projects is, the UHPC is being paved, it comes out. In North America, we always add curing compound on the UHPC to prevent any dehydration, and then a plastic poly cover on top, just to ensure that the material can cure properly. For winter operations, you may need some curing blankets. And what we're also doing is, you're now paving a long distance, we're using maturity method. The maturity method works very well for UHPC because there's not a lot of variance in the material. We use sensors in there, and then we can know exactly when the strength gain comes, when can we start grinding and grooving, which is usually done around 11 KSI. Material works very well for grinding and grooving. The traditional grinding equipment and grooving equipment can be used. We have seen decks that just had grinding. If you add the grooving, you really get a nice, very smooth ride on that particular bridge deck. I'm going to pass it over to Gil, who's going to talk about some of the projects we completed.
We've done a number of projects. One of the big signature projects we did was a test project for the Delaware River and Bay Authority. They put together a test program where they were going to do 3 sections, about 200 to 300 feet each, one in suspension, one in a truss area, and one in a girder area. It ended up being about 300 yards of material, and they really liked the outcome. You could actually feel the difference on the deck once that UHPC had cured. That span was more solid. It reduced the vibration because that UHPC was on there. The depth of the UHPC was about 3 3/4 inches. We had our largest placement one night. We did 90 yards in 8 hours. We used a thin lift paver. We had 4 mobile mixing plants there to feed that machine and make sure you were getting all the material down in front of it to keep everything moving. The demonstration project was so successful that the DRBA is now putting out a project for the entire northbound structure, which is a 2-mile structure. It's about 4,000 yards of UHPC that they're going to put in this overlay. That's pretty significant for the UHPC industry and for all of us that work on bridges to see how this material is applied on a large structure. Of course, Delaware Memorial Bridge is on a I-295. It's a northwest connector for the East Coast, about 80,000 ADT, so that's a significant project. We also did 3 bridges for a test program for the New Jersey DOT in 2020. They had a couple of the bridges ended up with an asphalt overlay on top of the UHPC, and one just rode on the UHPC. They also replaced headers on one of the bridges on 280, I-280, which is in Jersey City and Newark. It was, the depth of the UHPC was about 3¼ inches, that we used hydro demolition for removal. Another project we worked on right in Queens was the Bruckner Expressway. They were doing an expansion program on the Bruckner, and during the project they had some deck scarification that went on, and they scarified a lane ramp which wasn't supposed to be scarified. So now they discovered there were some problems with punctures into the T-beams, and they damaged them. So they were really worried about a reduced structural capacity on this structure. They called us in a week. We mobilized and we put a UHPC overlay on for them. It was tough traffic conditions, lots of New York drivers going by at 80 miles an hour, and they're angry that the ramp is closed. But we went out there. This was such a small project that we did use a screed for the application. It did a great job of getting that thing open to traffic in a short time period. One of the other projects we did in 2020 was the Commodore Barrie Bridge. This is a bridge between Philadelphia and New Jersey. It's a signature bridge. They were interested in looking at UHPC for not only a test on the Commodore Barrie Bridge, but also on a bridge, an interstate bridge in New Jersey, which fed into the toll plaza, Route 322. Overall, we placed about 300 plus yards between the Route 322 and the girder span, which was a smaller section. They haven't made a decision yet on if they want to continue to do more with UHPC. I will tell you that it was about a 4-inch overlay. You can see in that center picture a lot of the rebar that's exposed. This bridge had numerous overlays on it, numerous patches on it. We had variable materials that during hydro demolition responded differently to the hydro. When we started our calibration, the first thing we did is blew through the deck, which is not something you want to do. But we quickly had to adjust to that. We had to go to actually a very shallow hydro demo, and there was a lot of hand chipping that was required to make sure we cleared under the rebar. One of the things I want to talk about is risk management here. So you as owners and design engineers need to understand what the risks are that you get into when you use UHPC. One of the biggest risks we find is quantity overrun. When you specify UHPC, there are some states that are specifying it by like an overlay, which would be in square yards, but it doesn't take into account the depth. And if you're going to use hydro demolition, you may not have a very consistent depth, because hydro demo takes out everything that's less than the pressure that you applied with the hydro demo. So it's going to take out the soft stuff, it's going to take out aggregate, and aggregate has a depth to it. So there's a variation in the depth of your hydro demo surface. If you were looking for 1.5 inches, it may be somewhere between 1 inch and 2 inches. And every time you add a 1/4 inch of UHPC, you're talking about lots of money. It's expensive stuff. It runs $3,000 to $4,000 a yard, okay? And that's just material. We still have to mix it on site. We still got to have quality control. We still got to get it delivered. So you add a 1/4 inch over a large structure, now you're talking about hundreds of yards. So if you specify that you're going to pay by cubic yards, what you're going to do is you're going to get tighter bids, because contractors what they don't know, they put more money in the bid to compensate for. Exposed rebar is an issue. When you talk about rebar, do you really need to expose the rebar? Do you need to expose under the rebar, or can you just expose the top of the rebar? That becomes an issue of, how much time does it take for the contractor to get that material out? Do they have to do hand chipping, or is hydro demo going to work? If there's repairs required between the hydro demolition and the UHPC, like full depth repairs that they want to do, how long does that take? That needs to be considered so that you're Whether you're bidding on just hydrodemo or bidding on UHPC or the package together, you know how to plan for that. Site access is difficult. You've got a big laydown area. When you talk about delivery of UHPC on a 300-yard project, you're talking about hundreds and hundreds of super sacks that are 4x4 that could be stacked too high. So you need a huge laydown area. You need ability to get trucks in all the time to constantly feed more UHPC in, and you need a good mixing area. Weather conditions, obviously, you don't want to be placing this in pouring rain. You can place it in drizzle. You don't want to be placing it when the temperatures are going to be really cold, because then you're going to slow down the curing process and you're going to have difficulty working with the material. Also for really hot weather. Depending on which material supplier you use, some of them respond differently to ambient temperatures that are over 80 degrees. It may seize up the material, so you got to think about ice and making sure that you've got the material cool enough. And last thing I'll say is about experience. If you're going to go into a job and specify UHPC for a joint fill job, a lot of contractors can figure that out. It's not really, really difficult. But if you're going to go into an overlay, you better check to make sure your contractor knows what they're doing. I've seen some of the DOTs that will put in a qualifications process in the bid. It's kind of like a check block yes or a check block no. Are you qualified to place UHPC and mix UHPC? I've also seen them require mock-ups, and I've heard of projects where they had the contractor do 4 different mock-ups to see if he could get it right before they went out there and did it for the one time. This stuff is going to reach 25,000 PSI. You don't want to have to go take it back out after you put it down. Quality. So on quality, there's a couple of things you need to consider. A pre-placement survey is really helpful because that's going to help you verify your quantity of UHPC and make sure that you're placing things at the right locations. You definitely want to do a dry run. We've worked on a couple of bridges where they were brand new bridges that were placed, and they didn't do a good dry run. And the rebar ended up a ½ inch below the top of the concrete. And the DOT didn't want to open up the bridge, and they put a big UHPC overlay on it. Well, that's just standard practice. You got to have a dry run, you got to check your clearances and make sure that everything's going to line up before you go for your record placement. No loose material on the deck. Peter showed you a beautiful picture of a hydrodemoed surface. You can't have loose material. All of that has to be gone. It has to be SSD, saturated surface dry. You need to make sure your contractor has backup equipment. What happens if the paver breaks down and you're in the middle of a placement? What happens if your mixer breaks down? And these things happen on every job we've been on. So we're always going out there with multiple pieces of equipment. We always have a backup. So if anything happens, we can keep the job moving along. You don't want to be halfway done and have to stop a UHPC placement. Curing and protection, really important. You want to get that thing, that curing compound down as soon as possible. And you want to put the plastic down right after that, and then stay off of it until it's hard enough to walk on. And then before it gets too hard, so I'm talking maybe about 10,000, 11,000 PSI, that's when you want to grind and groove. If you wait till this stuff gets up to 18,000 PSI, you've got a big problem. It's going to be a lot harder to grind and groove. You also need to be really careful with your grinding and grooving to make sure that they get the rye that you're looking for. I think that's often overlooked, the quality control on grinding and grooving. On specifications, there's a lot of variability in specifications across the different states. Some have more performance type specifications, others have material specifications. I talked about mock-up requirements. You can specify equipment selection if you'd like, and then how to handle your pay items. We always recommend that you place you put your pay item for your material used in cubic yards, so that your contractors know how to bid it.
So this is one I just want to remind everybody in the room. If you haven't heard about the Everyday Counts initiative for this year, EDC6, that's for 21-22. Federal Highways is providing a lot of support to the DOTs right now. It's UHPC for bridge preservation, overlays, joint link slabs, and girder end repairs are part of the program. Please reach out to Zach Haber. They have an excellent training program right now, day 1, day 2 programs. They really go through the design, how to work with UHPC, benefits and the advantages. So this is available for this year and next year. So it's very easy for you to get access to that.
Okay, last slide. How do we help owners and designers? Our booth is out here if you'd like to talk to us, but we're our trusted resource for UHPC placement. I can't guarantee I'm going to get any job that I help look at early in the process, but we've had a lot of experience working with all the different material suppliers in North America, and we do a lot of work with DOTs and designers to take a look at a preliminary project and help them understand how they can use UHPC. So please give us a call if you need something.
Thank you very much.
Right.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.